Hi everyone, my name is Bismarck Adumakun and welcome to my course, Visualize Data Trends with SQL Server in Power BI. I'm a Cloud Solutions Architect, Data and AI at Bismarck Incorporated, where I specialize in building complex analytics models. Ever wondered how extracting meaningful insights from SQL Server database is pivotal for informed decision making? In this course, you gain the ability to unlock the potential of your data for strategic decision making. Some of the major topics that will be covered include integrating SQL Server with Power BI, visualizing temporal trends, detecting anomalies, and creating dynamic and interactive dashboards in Power BI. By the end of this course, you will possess the skills and knowledge needed to extract data and visualize data trends from SQL Server database with Power BI. Before beginning the course, you should be familiar with SQL Server database and Power BI. I hope you join me on this journey to learn about Power BI and SQL Server database with the Visualize Data Trends with SQL Server and Power BI course at Pluralsight. While SQL Server databases house a treasure trove of information, extracting insights and creating visualizations solely through SQL scripts can be cumbersome and challenging. Here's where Power BI steps in as your dynamic ally, streamlining the process and unlocking new possibilities. Join me as we explore how Power BI effortlessly integrates with SQL Server, allowing you to import, transform, and visualize data with unparalleled ease. We will not only discuss the concept, but showcase the practical magic of connecting SQL Server to Power BI. Discover the art of creating compelling visualizations, unraveling temporal trends, identifying correlations, and detecting anomalies, all made achievable and visually stunning through the seamless marriage of SQL Server and Power BI. In this demo, you will master the art of identifying SQL Server connector in Power BI and importing, profiling, and transforming data with seamless efficiency. So first things first, we will navigate the Power BI interface. Imagine Power BI as a data playground and SQL Server as a treasure chest waiting to be opened. The key to this treasure is the SQL connector. After finding the connector, the real magic begins: importing, profiling, and transforming data. These are the crucial steps that transform raw data into meaningful insights. Let's take a look at the data we have in our SQL Server. We will start in Azure Data Studio. Although SQL Server Management Studio is equally suitable for this purpose, the key is connecting to your server. Today we are using a local SQL Server instance with SQL login for authentication. Let's explore the data we have to work with. You can see there are three databases: finance, human resources, and insurance databases. Let's take a quick glance at the table we will be working with in this demo. The price and risk table in the insurance database. Selecting the top 100 rows show the list of columns in the table and the data sample. In Power BI, we are going to connect to the SQL Server database. In order to do this, we need to use an SQL Server connector. Click on Get Data and select More. In the pop-up that appears, navigate to Database, and then select SQL Server Database and click on Connect. From the new pop-up that appears, put in your server details and an optional database. For now, let's just specify the server and click OK. When prompted, provide your connection credentials using a username and password to your SQL Server database. Note that I was not prompted because I have already authenticated with Power BI. From the pop-up that appears, locate the table as we did in Azure Data Studio. Drop down on the Insurance DB database and select the price and risk table. You can equally preview the sample data and click Transform Data if you want to further transform your data. Let's go ahead and then load the data by clicking Load. The data loading process may vary in duration contingent upon the data size you are importing. Let me demonstrate another way we can connect to our SQL Server database. Click on SQL Server and this would open the pop-up. Input your connection string. Power BI offers two data connectivity modes: Import and Direct Query. Import mode is suitable for smaller data sets, allowing for swift data manipulation within Power BI. Direct query mode, on the other hand, is preferred for larger data sets, as it queries the data source in real time with each interaction in Power BI. In our initial approach, we opted to import the entire pricing risks table. However, specific analysis may require more refined data sets. Power BI's advanced options facilitate this by enabling us to execute SQL queries directly, allowing for the extraction of only the necessary columns or records. Let's proceed with crafting an SQL query to isolate the columns relevant to our demonstration. This step demonstrates the flexibility of Power BI in handling complex data extraction tasks, especially useful when dealing with multiple databases on a single server. Go ahead and click OK. This should preview the result of the query, where we can either transform the data further or load the data into our Power BI canvas. Upon finalizing our query and loading the data into Power BI, it's automatically labeled as Query 1. For clarity and ease of reference, we will rename it to Pricing and Risks. This labeled dataset will serve as the foundation to our upcoming demonstrations, illustrating the powerful synergy between SQL Server and Power BI in transforming raw data into actionable insights. In this demo, we are immersing ourselves in the dynamic world of temporal trends using Power BI. Think of time as a storyteller and Power BI as a canvas where we will paint these narratives. We will walk through the diverse techniques for representing time-based data. Not every visualization is created equal when it comes to trend analysis, so we will demystify the art of selecting the perfect visual to narrate your temporal trends effectively. Now, armed with the knowledge of time-based data techniques and appropriate visuals, we will delve into the process of creating dynamic visualizations that tell a comparing story over time. Selecting the perfect visual to represent time-based data involves understanding the nature of your data and the story you want to tell. The Pricing and Risks dataset is an insurance dataset consisting of premium amount, insured amount, risk score, location, and policy start date for each insurance policy. Time-based data or time series data typically involves tracking changes over intervals such as days, months, years, or even minutes and seconds. Let's use a line chart to demonstrate the average premium amount trends over time. For time, we will use the policy start date. At a glance, you will see how the average premium amount shoots from 1,100 in 2022 to 1,500 in 2023. The trend continues to fall and rise at a regular interval through to 2030. This is showing the trend at the year level. Additionally, we can use the drill through bottom of the line chart visual to expand down levels in the date hierarchy, showing the average premium amount by year, quarter, month, and even day. In addition to the line chart, we can add a trend line to visualize how the data trends, positive or negative. Let's visualize trends by using the scatter chart, plotting the policy start dates against average risk score. This shows a similar trend like the line chart. In addition, you can easily identify anomalies or outliers using the scatter chart. You can equally drill through the visual and observe the trends over the date hierarchies and include a trend line. Another fascinating trend we can analyze is a trend of premium amount by location using the map visual. While this does not provide a trend over time, it allows us to identify concentration of a measure by location. This provides a more visually appealing approach to comparing different dimensions. In addition to all these visuals, we can regulate what we see with a date filter. This will allow us to filter the data according to specific date ranges to reveal trends for that duration. Some considerations to select perfect visuals for representing time-based data are understanding of your data and objectives, consideration of the audience and the context, and then choosing the right type of visual. For example, line and area charts for displaying trends over time, bar charts for comparing time periods or categories with discrete values, column charts for showing changes over time for a single series or comparing changes across multiple series for a limited number of time periods, scatter charts for visualizing the relationship between two variables over time, especially if the data points are numerous and not even spaced in time. We will dive into the fascinating realm of anomaly detection using the mighty Power BI. Anomalies, those unexpected deviations in the data, can hold invaluable insights or signal potential issues. We will understand why detecting anomalies is crucial. With the knowledge of why anomaly detection matters, we will build visualizations that spotlight these outliers using the visuals in Power BI. Anomalies, also known as outliers or aberrations, refer to observations in a dataset that deviate significantly from the majority of the data. Let's do a visual inspection of anomalies using the line chart from our previous demo. Copy and paste the line chart on a new tab. Click on the line chart and navigate to further analysis on the visualization pane located at your right hand. Toggle the Find Anomalies button. This will initially show the range with which anomalies will be detected. Go ahead and drop down on the selection to reveal further configurations. Increase the sensitivity to 100% to detect the slightest outliers in our data. Note that your use case will determine the level of sensitivity to apply. Power BI is able to provide explanation of the anomalies based on the variables we select in our datasets. Let's go ahead and then use the premium amount and a risk score to provide the explanation. When you are done, click on Apply. In addition, you can change the marker and then the color. From the line chart, you can see peaks and dips, which deviate from the expected values. To see explanation for this anomaly, click on the marker. This will reveal the anomaly explanation on the right-hand pane. This anomaly shows that the average of premium amount was unexpectedly high and has a value of 2,400, which is above the expected value of 2,100. At the moment, Power BI is unable to give any significant explanation for this anomaly. Let's include the insured amount as another variable to consider for the anomaly detection. This still does not give us any significant explanation. We can get explanations of the other detected anomalies by clicking on the corresponding markers. We can equally drill up and down the hierarchies. Let's see another visual way of detecting anomalies with a simple scatter chart of average risk over time. From the scatter chart at the year level, you can observe that most of the data points fall within the ranges of 0.78 and 0.8. However, you can see a risk score of 0.76, which deviates significantly from the observed range. You can visualize a trend by including a trend line. When implementing anomaly detection in Power BI, it's essential to choose the method that aligns with the characteristics of your data and the goals of your analysis. The choice often involves a trade-off between simplicity and sophistication based on the specific needs of your business or analytical use case. In this demo, we will embark on a journey to unravel the mystery of correlation analysis using Power BI. Before we dive into Power BI, let's understand the foundational concept of correlation analysis. Think of it as a detective work of data analysis. We are on the lookout for relationship between variables. I will break down the importance and the relevance of correlation in making informed decisions. Equipped with the knowledge of correlation analysis, we will put on our detective hats and identify correlations within our data sets. Correlation analysis is valuable in understanding how changes in one variable might be associated with changes in another. However, it's crucial to understand that correlation does not imply causation. Power BI offers several tools and features to identify and visualize correlation in your data. Scatter plots, correlation metrics, correlation coefficient measures, and then heat maps. Correlation analysis is a statistical method used to evaluate the strength and the direction of the linear relationship between quantitative variables. The result is expressed as a correlation coefficient, a numerical measure ranging from -1 to 1. A correlation coefficient of 1 indicates a perfect positive linear correlation. A correlation coefficient of -1 indicates a perfect negative linear relation. A correlation coefficient of 0 indicates no linear relationship. We will identify how each of the three variables, premium amount, risk score, and insured amount, is associated with the other. Let's start with analysis between average premium amount and average risk score. over the policy start date. You can draw down the date hierarchy to the quarter level. We then add a trend line to show the direction of the trend. This shows a positive upward trend, which signifies a positive correlation. To calculate the correlation coefficient, we can use a quick measure and select correlation coefficient from the mathematical operations section. We will use the average premium amount as the X measure, average risk score as a Y measure, and policy start date as a category. After adding the quick measure, we are presented with a DAX script Power BI generated to create the measure. Note the name of the correlation coefficient measure as average of premium amount and average of risk score correlation for policy start date. Yes, I know this is quite long for a variable name. You can rename that if you want, but for the purpose of this demonstration, I will maintain this name to give me a quick guess of what the measure is calculating. Let's go ahead and then visualize the measure with a gauge dial. We can create a new measure, max, with a value 1 to be used as a perfect positive correlation value. We will also update the gauge dial by setting the maximum value to max. From the gauge dial, we can see the correlation coefficient is 0.89, which shows quite a strong relationship between the average premium amount and average risk score. Let's go ahead and identify the correlation between the average premium amount and the average insured amount over the policy start date by simply copying and pasting the earlier scatter plot and replacing the y-axis with the average of insured amount. You can observe the title of the visual changes accordingly. We will create another correlation coefficient measure like we did earlier by clicking on Quick Measure and selecting Correlation Coefficient from the available calculations. We will use the average premium amount as the X measure, average insured amount as a Y measure, and policy start date as a category. Once our new measure is added, note the measure name. Let's duplicate the previous gauge dial and replace the value input field with this new measure. From the gauge dial, you can observe an even stronger correlation between the average premium amount and the average insured amount, with a correlation coefficient of 0.97. Let's identify the correlation between the average risk score and average insured amount over the policy start date by repeating the steps before. From the gauge dial, you can observe the correlation between the average risk score and average insured amount with a correlation coefficient of 0.86. We can agree that the relation between the premium amount and the insured amount is the strongest. Correlation provides insights into potential predictive relationships. If two variables show a consistent pattern of change together, it suggests predictability. When working with correlation in Power BI, it's essential to not only identify correlations, but also interpret them in the context of your data and business objectives. Additionally, always keep in mind the limitations of correlation analysis, such as the sensitivity to outliers and the assumptions of linear relationships. We will delve into the art of extracting meaningful insights and crafting actionable reports and dashboards using SQL 7 Power BI. This module is a crescendo of skills, a culmination of our journey through the intricacies of data analysis and visualization. In the data-driven landscape of today's business world, extracting meaningful insights from your SQL database is akin to uncovering hidden treasure. Raw data, while valuable, becomes a true asset when transformed into actionable insights. In this demo, we will develop and test SQL scripts in Azure Data Studio and use the SQL queries to extract data into Power BI. In Power BI, the process of extracting meaningful insights starts with connecting to your SQL Server database by doing the following. Connect to the SQL Server, input the server details, craft the SQL query, preview and transform the data, and load the data into Power BI. In this demo, our focus will be crafting that SQL query. Although Power BI gives us the query input field to write our query, it is often not the best way to test the output of your query. Ideally, you will write and test your queries in your database IDE, such as SQL Server Management Studio or Azure Data Studio in our case. Let's head over to Azure Data Studio. I have here a SQL Server database containing critical information. We will start with the customer retention table. Dropping down on columns reveals the columns available in the table. Let's go ahead and select the top 1,000 records from the table to show the data in this table. Now, let's craft a query to extract insights. Firstly, we might want to remove two columns which are sensitive, the customer first name and the last name. Let's add two custom columns: policy status, active when the policy end date is greater than the current date and inactive when otherwise, and income group, high when the annual income is greater than or equal to 150,000, medium when annual income is greater than or equal to 90,000 but less than 150,000, and low when otherwise. Again, let's drop down the insurance fraud prevention table and review the columns under that. Selecting the top 1,000 rows shows the data in this table. Let's exclude the insured name column as it contains sensitive information. Back in Power BI, we are going to now load the data set using our crafted script. Using the same approach of getting data from SQL databases, let's copy the query from Azure Data Studio and paste in the Power BI query input field. Note that when using the SQL statement to extract data from SQL databases, the database name is required. Click on OK, preview and load the dataset into Power BI. Once loaded, we will rename the dataset to Insurance Fraud Prevention. Here, you can witness the columns we scripted in Azure Data Studio have been made available in the Power BI data pane. We will repeat the same process to retrieve the second dataset using the earlier crafted query. Again, get data, copy and paste the query from the Azure Data Studio into Power BI query input field. Check that you have the right query, specify the database, and click OK. Preview and load the data. Let's rename the dataset to Customer Retention. These datasets form the base of our next demo. It's time to breathe life into these insights through the art of report design in Power BI. Reports aren't just about data, they are about communication and empowerment. I have a set of extracted insights, and our goal is to design a report that not only conveys information effectively, but also inspires action. In this demo, we will develop reports to analyze customer retention and identify potential fraudulent claims. Let's start with a pie chart of the number of customers by policy status, the custom column we created. From the pie chart, we can easily observe that 96% of the customers are active and 4% are inactive. Let's rename the chart to Count of Customers by Policy Status. We will also create a bar chart of the number of customers by income group. From the chart, you will observe the majority of the customers are medium income earners. Let's rename the chart to Count of Customers by income group. Let's add a card visual showing the average annual income of customers. This displays $106,450. We will also add a filter for the occupation of customers. This will allow us to filter the report according to customer occupation. We can edit the visual and make the slicer style a drop-down. This is useful when you have many dimensions to select from. Let's add an additional shadow effect to give the visual a 3D look. Let's add a donut chart of the number of customers by gender to show the gender distribution. Rename the chart to Count of Customers by gender. Let's duplicate the occupation filter visual and replace it with policy type. Now, with the policy type filter, we can slice the report by policy type. Let's create a pivot table with income group as columns, policy type as rows, and distinct count of customer IDs as values. Let's quickly reorder the visuals and rename the current tab as Customer Retention. We will create an additional tab and name it as Fraud Prevention. Let's create a simple table of claim ID, claim type, claim amount, and investigation status. This table will give details of potential fraudulent claims submitted by the customers. Let's create a date filter with the claim date column, which we will use to filter the details by date. Another filter with claim type will be created to allow us to slice the data accordingly. Finally, let's create a decomposition tree visual to break down the number of claims by the investigation status. Use the claim ID as the analyze field and investigation status as the explained by field. Expand the decomposition tree visual to review the investigation status that make up the total number of claims. Let's add a shadow to the visual to give it a 3D look. We will start by publishing our Power BI report to the service, selecting a workspace where our insight will reside. Once published, we will pin visuals from our reports to a new dashboard named SQL Trends, demonstrating how Power BI dashboards acts as central hubs of consolidated data visualization. As we navigate through the dashboard, we will explore the benefits it brings, from real-time data monitoring to interactive exploration. The power lies not only in the visuals, but in the way users can engage with them. We are going to create a dashboard in Power BI service. This will require that we save what we have done so far and publish our Power BI report. This stage will require an active Power BI license. You can also sign up for a free trial. Let's go ahead and click Publish to publish the report. Choose the workspace to publish the report to and click Select. This will deploy the report to that workspace. Once the report is published, the link to the report would be generated. You can access the online report by clicking on the link. In Power BI Online Service, a quick check will show all the report tabs we have published. To create a dashboard in Power BI, you simply will pin a visual to the existing or new dashboard. You can pin as many visuals as you want. Let's go ahead and pin visuals to a new dashboard called SQL Trends. Let's pin visuals from each report tab. Power BI dashboards are a great way to represent visuals and information from different reports. It gives a good overview of the report and allows users to see more when they select a visual in a dashboard. Power BI dashboards offer a multitude of benefits, empowering organizations to transform data into visually compelling and interactive narratives. Centralized data visualizations, real-time data monitoring, interactive data exploration, consolidated view of multiple data sources, alerts and notifications, and integration with other Microsoft tools. You can navigate to the created dashboard by clicking on Go to Dashboard or selecting the workspace. On the SQL Trends dashboard we created, you can see all the visuals we pinned. You can rearrange the visuals as you want it presented. Note that clicking on a visual on the dashboard leads you to the Report tab that contains that visual. Due to the interactive nature of Power BI dashboards, you can add comments to specific visuals. In this example, I will add a comment asking myself about the importance of the visual. Power BI automatically sends an alert email to me with a link to that comment. This is a great way for report users to interact with BI developers, share ideas, and request change. This is an example of a notification email sent to my mailbox by Power BI. Clicking on the link redirects to the exact comment. A quick review of the report tabs and utilizing the filters shows the dynamic nature of Power BI.